Hey there, welcome to this video, 2C-3 Part B. We are going to solve logarithmic equations using technology, a tool that you guys have on the AP exam, and so we'll go into that. With my students, I use both Desmos as well as TI and Spires, so if you have either of those tools, which on the AP exam you will have access to Desmos, so that will be helpful in utilizing that tool to help you solve these equations, okay? So, we are going to go ahead and solve logarithmic equations using technology, and you'll be successful if, one, you can graph a logarithmic function using technology. Again, we'll go over two different tools here. If you can find the intersection of two functions, again, using technology, and you can evaluate a logarithmic function using technology, okay? So, at this point, you may want to go ahead and have your graphing technology nearby. You can go to desmos.com and open up a graphing calculator. It looks something like this, or have your other calculator nearby, okay? So let's go ahead and actually we'll stay out of full screen. Let's look at the first example here. Contextually, sodium-22 is a radioactive isotope, and the function T of S is equal to negative 3.704 natural log of S over 50 can be used to estimate time T it will take in years for 50 grams of the isotope to reduce to S grams. They say determine the amount of sodium-22 that will remain after 20 years as a decimal approximation. The first thing that I like to do in these questions is identify, okay, what are my variables? What's my input? What is my input? And here my input is S, and this is in grams. This is in grams. So sodium-22, I think, is what this represents in grams. And my output, what we get out, is T. And then this is time. This is time it will take for it to reduce, okay? And then, so again, I think they said here in years. So this is in years. Now, in identifying input and output is important because usually two things will happen with these types of questions. One, I'll have to evaluate, so I'll have to plug something in and determine what it is, or I have to go ahead and set something equal to something to solve. So A says determine the amount of sodium-22. So what is the amount of sodium-22? That's S. I don't know what that is. Determine it. That will remain after 20 years. So what they give me is T is equal to 20. So when we look at our equation up here, I don't know what S is. I need to solve for the input. And they give me the output T equals 20. So my output is 20. So I'm going to rewrite this equation. So they want me to solve when is 20 equal to negative 3.704 natural log of S over 50. Okay, and so here's where graphing technology comes into play. I'm going to write that down, and then I'm going to go to my calculator, and I'm going to do two things. One, I need to graph 20, so y equals 20. I'm going to graph that. I don't see it because I'm zoomed out, or zoomed too close in, so I'll go ahead and zoom out. Now I can see it. And I also need to graph my function. Okay, so my function is called T of S, but I'm just going to put X, T of X. Desmos does not like, different input variables, so we'll use X. Negative 3.704 times the natural log. Again, if you need your functions, you can click the keyboard and then go over here to functions. Or, natural log is nice. You can literally just type in ln, but here it is. Here's ln. It's not in, it's ln for Logarithmus Naturale. Remember, it's Latin. Okay, of x over 50. So there's my function. There's my nice logarithmic function with a negative reflection. And we can see they intersect right here. So that's when they're going to be equal. And it looks like our t value is 0.22593. So this is going to occur. So S is equal to 0.226. Okay. Always, always, always 3 decimal places. And remember, this is in terms of grams. So after 20 years, there will be 0.226 grams of sodium-22. Although I don't think units are required, but anyway, yeah. Okay, B, find T of 13 and explain what it means in the context. So whenever they ask you this, make sure you label T of 13 equals, and then it's really easy. I'm just going to go to my calculator. I'm going to say, okay, what is T of 13? I'm just plugging it in. And so that is equal to 4.990, or you could truncate 4.989. Okay, and they say explain what this means in terms of the context. So what does this mean? What does this mean? Well, we need to go ahead and identify this. Okay, so we can say there will be, our input is S. S is equal to 13. What is S? That's sodium 22. There will be 13 grams of sodium 22 in 4.990 years. And if your teacher is really picky about the word about, use the word about. In about 4.990 years. Okay? That's what it is. That's what it means. My input, sodium 22. Output, time in years. Make sure you use units. Context, units, and then of course, well, here it's kind of reversed, times the output. Okay, second example. I'm going to go ahead and I'm going to switch technologies. So you can keep using Desmos if you want, but I'm going to switch over to the TI Inspire just because I use both in my classroom. And this example says the function d is given by d of x equals 13 log base 5 of x. For what input value in the domain of d is the output value 19? Write your answer as a decimal approximation. So they want the output to be 19, and students always get tripped on this. They're like, I don't know what that means. Well, that just means you set your function equal to that value. I want this to be equal to 19. Okay, and I guess technically, you could solve this, algebraically as well as graphing. So you know what? Why don't we do both? Let's do both. That sounds fun. So okay, I'm gonna go ahead. I'm gonna undo that 13. I'm gonna divide both sides by 13. Bink, bink. And I get log base 5 of x equals 19 over 13. What is that value? I don't know. I don't care. Now I'm going to undo the log base 5. How do I get rid of that? Well, I'm going to raise both sides by 5. Okay, so x is equal to 5 to the power of 19 over 13, which, let's see what this value is. Let's go to TI Inspire. I'm going to add a calculator, and we're just doing 5 to the power of 19 divided by 13. And let's see what this is. 10.509. 10.509. Okay, there you go. Pretty easy. But what if I wanted to go ahead and graph it to solve this? Okay, we can do that too. So I'm going to go in my TI Inspire to a graph, and I'm going to graph two things. Again, I'm going to graph 19. Okay, you can't see it here, but I could go ahead and I could zoom out. There it is. And then I'm going to add a second graph. Hit tab, you can add a second graph, and I'm going to graph my function. It was 13 times the log base 5. So logarithm, here's log right here. It's the secondary function to 10 to the power of x. Type in log, and the TI will ask you, log base what? If you leave it blank, it'll assume it's 10. So make sure you input it because we did not have 10 there. Okay, so log base 5x, boom, beautiful. Hit x, and ta-da, that's where they touch. So there's my answer. Menu, analyze, intersection. Click, click, and there you go, 10.509. So, two different ways. You could do that one algebraically or graphically. I guess you could do the same thing here, but that might be more nasty. I'm not as, in favor of doing example 1 that way. Okay, I have two practice problems here for you. I'll go ahead, pose the question, and I'll pause the video and then see if you can do it. And I'll kind of flip it here. I'll do this one, I'll do this one again with Desmos, and then this one with the TI Inspire. Okay, so pause video, and then we'll address question A and B. Okay, let's look at this practice problem. Here I have k of x equal to 7. They define k as 5 natural log x. So I set them equal to each other and we graph, and then there is the intersection. We can see this here, that they intersect at this location, which is 4.055. All right, you could also do this algebraically. You could go ahead and divide both sides by 5 and then undo the natural log with base e, if you remember that, and you would get e to the power of 7 over 5, which is the exact same value. Okay, so there's your answer. Next, determine the end behavior of k as x increases without bound. Well, that is the limit of k of x as x goes to infinity. So what is that? Well, if we look at our graph, look, our graph is going up. And it's going to keep going up forever and ever and ever. So our answer is positive infinity on that one. How'd you do? Did you get it? Awesome. Last practice one here. It is the time it will take for a pot of stew to reach a certain temperature T in degrees Celsius once the pot has been removed from the stove can be modeled by a function m of t equals negative 25 log of t minus 20 over 50, where m is in minutes. After 15 minutes, what is the temperature of the pot of stew as a decimal approximation? Go ahead, use technology to go ahead and answer this question. Again, I'll use Desmos, or not Desmos, I'm going to use the TI Inspire to help me solve this one. But pause me, try this one. Okay, I'm going to go ahead and jump in, pause you, maybe help you for a second before I show you the answer. Note, I like to, again, identify what's my input and output in context. So the input here is T, that's temperature. So your input is T in temperature. Your output is M in minutes. So what are they asking you? What do they give you? Identify that, okay? I'll go ahead and show you the answer here in a second. Pause me. Okay, so hopefully you identified that they give you 15 minutes. That's the output. They say after 15 minutes, what is the temperature of the pot of the stew is a decimal approximation. So you're solving for T, which is the input. So we're going to have to solve graphically, or I guess you could solve this algebraically, but we're going to graph negative 25 log of t minus 20 over 50, again, use x. We graph it, here's what it looks like, and then I'm going to graph the line 15, and then their intersection is the solution. So menu, analyze, and we want intersection. So that's how I find where these two touch, which that answer is going to be 32.559. And there you have it, folks. That will be the temperature in Celsius, 32.559 degrees Celsius. Okay, so yeah, that is it for this video. Hopefully you guys learned how to use Desmos and the TI Inspire to solve logarithmic equations. Give me a thumbs up, like the video, subscribe for more awesome math videos. See you in the next lesson. Bye.